Just record everything stable that we've just created. Now we only care about the items whose
I am looking at the
category is electronics,
experience to them to
developers to manage a Postgres database. And Supabase itself is just Postgres. So we can interact with this data in any way you like. So this can be directly through Postgres' own connection string using an ORM like Prisma or Drizzle, or using Supabase's own client-side libraries like Supabase.js. So in this video, I want to show you a high-level walkthrough of the process that happens behind the scenes whenever we use Supabase's own client-side libraries, from the moment that we initiate the query all the way till we get this data back on the client, because this query actually goes through an entire process to efficiently and securely retrieve this data. And this process itself is just Postgres, so we can interact with this data in any way you like. So this can be directly through Postgres' own connection string using an ORM like Prisma or Drizzle, or using Supabase's own client-side libraries like Supabase.js. So in this video, I want to show you a high-level walkthrough of the process that happens behind the scenes whenever we use Supabase's own client-side libraries, from the moment that we initiate the query all the way till we get this data back on the client, because this query actually goes through an entire process to efficiently and securely retrieve this data. And this process starts with the query builder provided by the client-side library. So first, we create a Supabase client by providing our project URL and also a public key, so we can now query data from our database. So in this case, let's say that we want to query data from the products table that we've just created. Now we only care about the items whose category is electronics, and we only want the name and price returned. So when this query is executed, the very first thing that happens is that the client library converts this into an HTTP request. So it transforms all these method calls into query parameters. So in this case, the URL consists of the project ID and also the table name, so products, and the methods are translated into specific query parameters. So we have select name and price, and the category is equal to electronics. The client now sends this request to Supabase's backend, and within the backend, it first hits the API gateway. This gateway essentially acts as a front door for all of these API requests, and it routes these requests to the right services in Supabase's backend. But it also adds some extra security features like DDoS protection. So in this case, the API gateway forwards our request to another service in Supabase's backend, namely Postgres. And Postgres is a web server in Supabase's backend that automatically creates a REST API based on our Postgres database. Now, when a request comes in, we get to the next step, because Postgres now converts this request into a valid SQL statement. So the select query parameter translates to selecting the name and price columns, and the category becomes a where clause. Now, this is a valid SQL query, so theoretically we could already query our database like this. But before doing so, Postgres first turns our query into a prepared statement. So a prepared statement is essentially a reusable template for your SQL query. And this is important because let's say that Supabase were to build our SQL query like this by concatenating certain strings. Now this could lead to a SQL injection attack. So for example, if someone passed in this input, they would trick the database into returning all products and not just electronics. Of course, this is a pretty innocent example, but you can imagine what else they can do with that. So this is why Postgres uses prepared statements. So it creates this template with placeholders, and it then executes this statement separately with the actual value of electronics. And this approach not only prevents these SQL injection attacks, but it also improves the performance because Postgres can actually cache and reuse these query templates for any future requests. Now, finally, it's time to send this query to Postgres and execute this statement. But there's one thing to consider first. When you're building an app and it goes viral, it can happen that suddenly thousands of users are making database queries at the same time. And each database query typically requires a connection to the database, but creating a new connection for every request would be really slow and also take up a lot of resources.